What if we built an artificial planet? Imagine the possibility of constructing an artificial planet, a vast, engineered sphere, designed and crafted by humans, or a hyper-advanced civilization, floating freely in the cosmos. To envision such an undertaking is to grapple with the very limits of technology, imagination, and ambition. But how might such a marvel come to be, and what would life be like upon it? As we embark on this journey through speculation, science, and the boundless creativity that defines our species, let's explore what it would truly mean to build an artificial planet. At the outset, consider the sheer scale of the challenge. A planet, even a small one by cosmic standards, represents an astronomical mass, millions to billions of trillions of tons of rock, metal, gas, and ice. The smallest rocky bodies, like the dwarf planet Ceres, span hundreds of kilometers across. Familiar Earth-sized worlds are over 12,000 kilometers in diameter. The construction of such an object would dwarf every engineering project in our history combined. But let's start at the beginning. Why would we want to do this? What are the motivations for constructing a world, rather than settling on or terraforming an existing planet or moon? There are many reasons. First, natural planets come as we find them. Their atmospheres, gravity, day lengths, chemistry, and more are dictated by chance. An artificial planet offers the promise of perfect customization. Gravity could be set to suit human physiology. Landscapes could be sculpted for beauty, utility, or both. The climate could be fine-tuned, free from hurricanes, blizzards, and droughts. Toxic atmospheres, deadly radiation belts, or unyielding deserts could be consigned to ancient history. Cities, forests, lakes, and mountains all could emerge as designed. Then there's the question of habitability. Planets in our solar system and beyond rarely offer the Goldilocks conditions so vital to life. Mars is too cold and dry. Venus is hellishly hot. The gas giants are little more than tempestuous balls of gas. Even exoplanets in the habitable zone might lack magnetic fields, inviting deadly radiation from space. An artificial world, by contrast, could be optimized for flourishing life, a cosmic sanctuary in the black wilderness. Beyond survival, there is the allure of legacy and ambition. The act of creating a planet is the ultimate expression of mastery over nature. It is Genesis on an industrial scale. Such an achievement might mark the transition of a civilization from planetary to stellar, or even galactic significance, a marker visible across the cosmos for eons to come. So, how would we begin? What would an artificial planet look like, and how could it be manufactured? There are several approaches, each with different scales, methods, and possible outcomes. The first is to imagine building a solid planet, a sphere of rock, metal, water, and atmosphere, just like Earth, but fabricated from the ground up. This is the hardest path, requiring the acquisition, transportation, and arrangement of astronomical masses of raw material. Where would we find the needed elements? The asteroid belt, rich with metal and rock, offers a tempting supply, as does the Kuiper belt, flush with ices. Moons and minor planets could be disassembled and repurposed, cannibalized to birth a new world. Perhaps even the debris of failed stars or ancient comets could be harvested, scooped up by fleets of mining drones or self-replicating robotic forges. The timeline would be immense, the resources similarly so. One proposal is the use of world-building engines, gargantuan rockets or nuclear engines that gradually shepherd vast masses together, melting and amalgamating their bounty into a bulk that eventually grows massive enough to pull itself into a spherical shape through gravity. As the protoplanet accretes, it heats and differentiates, with heavier elements sinking to form a molten core, while lighter silicates and water accumulate near the surface. The formation period could last centuries, millennia, or eons, depending on resources and technological prowess. In the final stages, a planet's own gravity and geological forces take over, compressing it into near-perfect roundness as it cools and solidifies. There are challenges, of course. The immense heat from accretion must be managed, lest the surface never cools. The nascent world could fracture from internal stresses, or erupt with volcanic fury. It might even fail to form a stable core, leaving it geologically dead and without a magnetic field. Each obstacle presents a frontier of science and engineering to be overcome. Alternatively, we could dream of a hollow world, a shell rather than a solid sphere. In science fiction, such structures abound, from the hollow Earths of the 19th century to the megastructures envisioned by modern futurists. One compelling variant is the shell world, as described by author Ian M. Banks, a series of concentric, inhabited layers, each resting atop vast support structures, stacked like the layers of an onion. These shells could offer vastly increased surface area, with vast habitable regions on each layer, connected by titanic elevators or tunnels. A more radical idea is the Dyson shell or Dyson sphere, not a planet per se, but a vast, thin structure that surrounds a star, capturing its energy for civilization's use. While a true continuous Dyson sphere is generally considered physically impossible due to material strength constraints, a Dyson swarm of habitats, stations, and mirrors might one day be realized. Another intriguing notion is the Stanford torus or O'Neill cylinder, huge rotating habitats that simulate gravity through centrifugal force. These are not planets, but can mimic some planetary conditions, and in theory, a series of such habitats could cluster to create a massive, engineered planetoid. But let us return to the idea of a true spherical, artificial planet. Once formed and cooled, it must be given an atmosphere suitable for life. This means releasing volatile compounds, water, carbon dioxide, methane, nitrogen, oxygen, stored in ice, harvested from comets, or synthesized chemically. Terraforming begins. Bacteria, algae, and engineered plants are introduced, their photosynthetic activity transforming the nascent air over centuries. The planet's rotation must be set, perhaps by the impact of directed asteroids or by the torque generated by giant engines. The length of its day, its seasonality, and axial tilt can all be carefully chosen, unlike on a natural world. A protective magnetosphere is essential to shield life from deadly solar and cosmic radiation. If the planet is large enough with a molten iron core, this may arise naturally. Otherwise, artificial magnetic field generators could be positioned at the poles or in orbit. With a breathable atmosphere and regulated temperature, life could flourish. Rain falls, rivers form, lakes and seas gather. Humanity, or its descendants, settle the surface, building cities, farms, forests, and networks of knowledge and culture. Perhaps vast sections are left wild for biodiversity and beauty. Energy, agriculture, industry, all are integrated from the beginning, with lessons learned from centuries of stewardship of our first home. But what about gravity? If the new planet is Earth-sized, gravity will be nearly identical. If it is smaller or larger, surface gravity could be adjusted by choice of mass and radius. Low gravity allows for towering structures and reduced energy cost for transportation. High gravity could prove physically taxing, but increases atmospheric retention. The optimal gravity would balance comfort, health, and utility. The ecosystem can be planned. Rather than the messy, accidental evolution of natural worlds, the biosphere could be designed with redundancy and sustainability in mind. Genetic engineering offers endless possibilities: resilient crops, non-invasive animals, new forms of life tailored for art, recreation, or ecosystem balance. Communication and transportation would integrate seamlessly into the planet's design. Hyperloops, maglev trains, or vacuum tubes could link far-flung continents. Power generation might use fusion, orbiting solar arrays, or geothermal energy tapped directly from the engineered core. Social organization, too, could be reimagined. Without legacy divisions formed by the accidents of geography, new cultural models might emerge, collaborative, equitable, and adaptive to the wonders of their world. But challenges persist. Even with ideal engineering, planets are hardly immune to catastrophe. Meteor impacts, even rare, remain a threat. Engineers might deploy planetary defense grids, arrays of lasers, railguns, or missile interceptors, forever vigilant against rogue asteroids or comets. The climate, though regulated by design, could still slip out of balance if mismanaged. Ocean currents, air circulation, and ice caps all need constant monitoring and adjustment. The governance of a whole world, even one built by humanity, presents political and ethical challenges unlike any before. And what if we dream even bigger? Suppose we construct multiple artificial planets, a solar system not of natural birth, but of conscious design. Worlds are set in perfect orbits for trade, culture, and exploration. Vast space elevators connect planet to orbit, moving goods and people effortlessly. Artificial moons provide tidal forces, stabilize climate, and offer additional habitable space. Perhaps even the sun itself is engineered, surrounded by mirrors to boost its light, or replaced by fusion reactors if it ever dims. At this stage, humanity would have truly become a cosmic species, shaping not just their home, but the very architecture of their solar system. The philosophical implications are profound. What is a natural world when an artificial one can be more welcoming, beautiful, and resilient? What happens to our sense of identity, tradition, and origin? Will we carry the lessons of Earth with us, or repeat old mistakes on new shores? Now, consider the possibility of non-human artificial planets. What if, one day, intelligent life elsewhere in the cosmos left evidence of their technological prowess, not in messages or artifacts, but in the planets themselves? Astronomers might one day detect worlds with spectral signatures of odd materials, titanium, diamond, or even exotic matter. Possibly the fingerprints of a constructed world. Perhaps there are structures far beyond our imagining, planets made not to mimic nature, but to fulfill other needs. Computronium spheres, worlds optimized for computation, pulsing with the thoughts of artificial intelligences, churning out new realities within their digital brains. Or perhaps their surfaces host alien cities, art, and life as strange to us as we are to them. Might such an artificial planet be a warning or a promise? The ruins of a failed venture, abandoned after some unknown disaster, or a monument to a civilization's enduring hope and creativity? Returning to the present, let's consider what might be needed to turn any of this into reality. Advances in material science, to develop ultra-strong, self-healing materials capable of supporting crusts and shells of planetary thickness. Automated mining and manufacturing on a scale hitherto undreamt of. Mastery of fusion and energy transmission for planetary heating, terraforming, and propulsion. Breakthroughs in AI, robotics, and perhaps even synthetic biology to manage ecosystems, repair infrastructure, and evolve solutions to unforeseen problems. Most challenging of all might be the political, social, and ethical coordination necessary to harness such power wisely. The resources needed for a planet are beyond the capacity of any one nation or corporation. New forms of global or even interplanetary governance may arise, dedicated to peace, sustainability, and the common good. And what of exploration? An artificial planet could serve as a way station, a launch pad for deep space voyages. Its construction might teach us to build even larger, more ambitious structures, ringworlds, starships, or habitats big enough to carry billions between the stars. We may find ourselves changed by the task as we change the universe. To build a planet is to redefine not just our home, but ourselves, a testament to the human drive to create, to endure, to reach ever outward. If such a world is possible, where might it be built? The most likely locations are within our solar system, somewhere between Mars and Jupiter, or out amidst the asteroids where raw materials abound. The reduced gravity and lower sunlight offer both challenges and opportunities. In the far future, artificial planets may anchor human civilization across the Milky Way, slowly building an archipelago of worlds where once there was only emptiness and drifting rock. The stories we tell about new worlds, their creation, habitation, and destiny, will become not only science fiction, but lived history. Artists, writers, and philosophers will find endless inspiration in the birth of new landscapes, the merging of the artificial and the natural, the promise and peril of forging new Edens from the dust of space. And so, we return to the question, what if we built an artificial planet? The answer is, in part, a reflection of our boldest dreams and deepest values. It is a future where technology is not an end in itself, but a tool for crafting beauty, community, and possibility on a scale no longer bound by the accidents of geological history. It is a future that calls us to stewardship, creativity, and humility in equal measure. While such a project lies far beyond our current reach, seeds are already being planted. Space mining is transitioning from fiction to frontier industry. Advances in robotic construction hint at the capacity for automated, large-scale assembly. The first space habitats, small as they may be, are being designed and, in some cases, built. Each new step pushes the boundary of the possible a little farther, drawing the outline of unimaginable feats still to come. Perhaps one day, the night sky will contain not just the points of light of distant suns and swirling clouds of nebulae, but new worlds, slowly circling, softly glowing, their surfaces humming with life and industry. Somewhere, children descended from Earth, or perhaps totally new intelligences born in the crucible of artificial worlds, will walk under a green and blue sky that once existed only in the imagination. For them, the act of planet building will be ancient history, a chapter in the long, unbroken narrative of humanity's quest to make a home among the stars. Until then, we look up, we wonder, and we build, stone by stone, code by code, dream by dream, readying ourselves for the astonishing moment when an entire planet's worth of possibility springs to life, and the universe grows just a little larger with the touch of human hands.